Hello everyone, I'm back. So now I'll start discussing 3.3, and on this um, lecture you will see the quadratic equation, or in other words the quadratic function. So this is how we define a quadratic function. Okay, ax squared plus bx plus c, where a can't be 0, and the simple reason is if a is 0, then this term is vanished, right? So it doesn't remain a quadratic function, because a quadratic function is the function where your highest exponent is 2, right? So that means if a is 0, you can clearly imagine this term is vanished, so then it will be a linear function instead of a quadratic function, okay? Because this guy has an exponent of 1 instead of 2. Okay, now we want to see different properties of this quadratic function. Okay, first of all, if you have a quadratic function of this format, let me write it this way. Let's say f of x equals ax squared. Okay, let's say these terms are 0. This can be 0, as you can see, because for a function to be quadratic, all you need is the exponent. The highest exponent has to be 2. So this is definitely a quadratic function as well. Okay, so that means this guy is 0. Bx plus c is 0 for this example. Anyway, so if you have a problem like this, where a could be any number, of course, what does this mean? Okay, now we want to see one example of this, and I think this will make your life easier, right? So we know that the graph of f of x equals x squared looks like this, right? We know that. That means here a is 1, right? Can you see that? Now what happens if we just take excuse me, f of x, let's say f of x equals a half x squared. Okay, so that means your intuition should say, let me use a different color. Your intuition should say, as you are multiplying this by a half, what does your intuition say? Your intuition should say this will actually, the entire function, of course, will be stretched by 2, right? Can you see that? Your intuition should say, from the stretching and compressing, your intuition should say this graph will be stretched by half, or sorry, my bad, by 2, right? Can you see that? So let me graph this. So this will be actually this, the new graph. This is, I'm using different colors, so take a look at this. This is for this, this is for this. As you can see from the color as well, white is for the main function, red one is for the stressed one. So we know that this graph will be stretched by 2, right? Now what happens if we take, let's say, f of x equals 3x squared? We are multiplying this by 3. So once again, your intuition should say the entire graph will be compressed by 3, right? So this graph will actually look like this. Okay, sorry for my bad drawing. Let me redraw it. It actually looks really bad. So yeah, it should look like this. So clearly, what's the conclusion? Let us come to the conclusion. So if we have a function like this, of course, a quadratic function, clearly this guy will give you a parabola. The shape you are seeing here, all of the three, we say this is a parabola. Okay, this is a new type of geometric shape. If you haven't seen this before, no worries. You will see more of this in Math 181, I believe, or at least in Math 127, that's for sure. Anyway, so this shape is called parabola, and so a quadratic equation or function of this format will always give you a parabola. Okay, not only this format, a quadratic equation generally gives you parabolas, but not always. We'll see examples of those, I believe. Anyway, so the conclusion is, if your A, that's the absolute value of A. That means if the value itself, not the sign assigned to it, that means it could be a -3, it could be a +3, doesn't matter. We only want to see the value, the magnitude. Okay, so if your A increases, then we say it's actually vertically stressed. Okay, vertically stressed. Okay, now what does this word vertically stressed mean? It means your graph will be taller. Okay, you can see that from this graph. Although this is not the exact figure, but if you have a graphing calculator, or if you have a laptop, you can always see the graphings changing the numbers. You'll see if your A is increased, your graph will actually get taller for a certain domain. Okay. Okay. Now, this clearly means your intuition should say if A is decreased and it's very close to 0, okay, then it's actually vertically compressed, right? Or in other words, it would say it gets shorter. Okay, you could say vertically compressed, or you might say it gets shorter within that particular domain. Okay. Okay, now if A is greater than 0, we say the graph opens up. You'll soon see what does this word opens up mean. And if A is less than 0, the graph actually opens down. Again, we'll see what does this mean in a while, but you can just remember this. What does this mean? Now, what does this word opens up mean? So in maths, we use the word concavity. So opens up means concave up, and opens down means concave down. That's a mathematical interpretation. Now, how does that look graphically? So concave up is this. You know, this looks like a cup, or you might say a bowl, you know, facing down, where this is the face and that's the empty part of your bowl, right? So this is what a concave up looks like, where you will have absolute minimum at the point here. At the lowest point, you will have an absolute minimum. Okay. So that's what happens when A is greater than 0. Okay. And your intuition should say for A less than 0, it should look like this. Okay. and that's for a less than 0. And of course, at the highest point, you will have an absolute maximum. Okay, and so that's your concave down, that's concave up. Okay. Okay, so for a parabola of this shape, your parabola looks like this. It could be actually drawn this way depending on, you know, you could actually have 4 different shapes like this. That's the general format depending on the values. Okay, all of these are parabolas. Whatever the shape is, the highest or the lowest point is called the vertex. That means on this one, this is the vertex. On this one, this is the vertex. On this one, this is the vertex. And on this one, this is the vertex. The highest or the lowest point, whatever your parabola looks like. Now we'll actually discuss more of these two, as you have assumed. So the highest or the lowest point is called the vertex. Okay. And now we want to see a particular example of it. Okay, that's what I like. So our example is f of x 3x squared minus 6x plus 5. Okay, and from this we want to find the vertex and the axis of symmetry. Now, what is an axis of symmetry? So if a vertical line goes through the vertex, then we say this is the axis of symmetry. So you need to have a vertical line. So for this one, that's your vertical line which goes through the vertex. That's your vertical line which goes through the vertex. So that's your axis of symmetry, okay? Axis of symmetry rather. We'd like to calculate that. So let us see this example, and this will actually make our life easier. Okay. So first of all, we'll actually reformat this example, and soon you will see why. Let us first reformat it, rewrite it. So we want to complete the square. If you remember from Math 95, 96, we have seen how to complete the square. So for that, I'll just factor out a 3 out of it, out of these two terms. So if I do that, I'll have x squared minus 2x plus 5. And you know the format of a minus b, the quantity squared, is a squared minus 2ab plus b squared, right? We already have a squared minus 2ab, where your a is x. Can you see where is your b? What if I say you have times 1 here, right? Anything times 1 is the same thing. So your b here is basically 1. So all you need is b squared. If I do that, let me write that first. Oops, sorry. 3 times x squared minus 2x plus b squared, which is b, which is 1, of course. Let me rewrite this way. 2x times 1 plus 1 squared. Okay, so that's a squared minus 2ab plus b squared. So now the square will be complete. But I just can't really add anything like this because I'm writing this equal sign, so the entire value has to remain the same. Okay, so the thing I'm adding, I need to subtract it as well. So I'm actually adding a 3. Can you see that? Because I have a 3 factored out here, I'm adding a plus 1 here. So overall, I'm actually adding a 3. So that means I need to subtract 3 as well to keep the value intact. Can you see that? I have added 3 here. I'm subtracting 3 as well on the right. So overall, all I'll get, if I just simplify this, is the second line. That means the value will remain the same. That's what we want. Okay, now as the square is complete, we can rewrite it as x minus 1, the quantity squared, using this format. Okay, and simplifying this, we'll get a 2. Okay, now we can use the concept from our previous concept. We know that if we add any graph or if we add 2 to any graph, this will actually shift vertically 2 units upwards, right? We know that. So this is basically your f of x. So if we add 2 to any graph, it will vertically shift to 2 units. We know that. Shift to upward, rather, not vertically shift. It will shift vertically upwards, vertically upwards by 2 units. Also, we know if we subtract 1 here, it will actually go to our right by 1 unit, right? You have seen this before. And we know if we multiply anything, or rather the function by anything positive, we know this will actually, the graph will actually get compressed by this unit, right? Okay, we know that. I think I've shown this here. Yeah, there it is. Oh, I said compressed. Sorry, I actually got carried away. Yeah, it would be vertically stressed as far as I can see. Yeah, so your graph will be taller. Here a is greater than 0. A is in between. Sorry, in between 0 and any other number. Okay. So if we multiply, I think it should be 1. Yeah, it should be 1. Yeah, precisely. So if we multiply by a positive number, which is more than 1, or in fact more than 0, precisely, it will be vertically stressed. So as we are multiplying this graph by a 3, your graph will be stressed by 3, right? So overall, as you can see, if we had a graph of x squared, now we have a graph of 3x minus the quantity squared plus 2. What this will give us is our graph will be stressed vertically by 3 units. It will move to our right by 1 unit, and it will be shifted upwards vertically by 2 units as well. Can you see that? So let me quickly use 2 more graphs. This will make your life easier. So that's our graph for the original y equals x squared. Okay, that's 0, 0. That's 1 and 2. Okay, sorry. It should be 2, that should be 3 and all that. Yeah. So now this graph will go upwards by 2 units. So instead of 0, 0, it will start from 2. Okay. It will move to our right by 1 unit as well. So instead of 0, 0, it will start from here. So because I am moving to my right by 1 unit. And of course, it will get taller or stressed by 3 units. So what this graph will finally look like, it will start from here. It will be stressed, so it will be taller. Something like this, okay? I'm very bad at drawing, sorry. Yeah, so this is what your graph will look like. Now, as you have the graph, or even though you don't have the graph, but as we now have the graph, we can actually see the vertex. And of course, we want to see the axis of symmetry. So this is our vertex as per our definition. So all we need is a vertical line which goes through that so that we can actually see the axis of symmetry. Okay. So as far as I can see, our vertex is at 1, 2. Can you see that? Because clearly we have moved to our right by 1 unit. We have went up to our or rather we have moved up by 2 units. So this point, instead of 0, 0, previously it was 0, 0, the vertex, right? But now instead it should be 1, 2. Can you see that? That's pretty obvious, right? And our vertical line which goes through the vertex, this guy, is actually x equals 1. Can you see that? Because we have seen that if we have a line like this, x equals a, this is exactly parallel to the y-axis, which goes through the value a in the x-axis. So this graph goes through 1. This is our 1, of course. On the axis, it's 1. The value of x is 1. It goes through this. It's exactly parallel to the y-axis. So our intuition should say this line is x equals 1. So this is our answer. Okay. Now, can we generalize this? Yes, we can. We can generalize this, of course. So let me write that for you. If we have a function like this, x squared plus bx plus c, we can actually rewrite this by completing the square in this format where h and k has a definite value, which is negative b over 2a, and k, k is 4ac minus b squared over 4a. That's the general format. All of these a's and b's and c's, all of these a's, b's, and c's does come from the original format. Okay, so this is the vertex form. Okay, this format is known as the vertex format. Okay, if we know this format, from this we can actually say what's our axis of symmetries and what is the vertex. Okay, so if we have this format, we can straight away say, hey, my vertex is of course negative b over 2a and the functional value there. That means what's the y value at that point. Okay, and the axis of symmetry is x equals negative b over 2a. You can always do that. Okay, now if we just go back to our previous problem, let's see whether it satisfies or not. What's the problem again? 3x squared minus 6x plus 5. 3x squared minus 6x plus 5. So first of all, we want to rewrite this in the vertex format. And we also have that. So let us waste no more time. That's our vertex format. 3 times x minus 1, the quantity squared, plus 2. So 3 times x minus 1, the quantity squared, plus 2. So that's our vertex format. And now if we just compare this, okay, we can see that, sorry. So we can see that our axis of symmetry is actually x equals 1, right? Now, in our main format, it was actually h. Can you see that? Your h is actually negative b over 2a. So this is literally, in other words, we'd say this is actually your h of this format, right? As you can see here. So basically the axis of symmetry is x equals h. Now, is it true here? Yes, as you can see, this is your h and this is your axis of symmetry. Same goes for the vertex as well. This is basically h and the functional value at h, right? So we can actually rewrite this as h comma functional value of h. That's your vertex. Now let's see whether that's true or not. Okay, so we have seen our vertex is 1 comma 2, right? Previously, let's see whether it satisfies or not. As I said, vertex is h comma f of h. So clearly h is 1. That's true. All we need to find is what's the functional value at h. That means at 1. So if we plug in values, excuse me, 3 times 1 minus 1, the quantity squared plus 2, this will be 0. The functional value at 1 will be 2. Exactly. So this is equal, right? This is exactly the same thing. So that means if you know, or if you have the vertex format, you can actually calculate the vertex and the axis of symmetry. Okay. Now, I'll show one more example before I go to the next topic. So, next example would be f of x equals negative 2x squared plus 8x minus 3. Okay, so that's the main function. And we want to calculate the vertex and the axis of symmetry. We can also see whether it's concave up or concave down, right? Okay, so first of all, we can clearly eyeball that our A is negative, and we know that if A is negative, then the graph is concave down, so we can say the conclusion that this will be concave down. Now, what about the vertex? We know the vertex is negative b over 2a and the functional value at that point, right? We know the formula. So let's just compare this. This is our A, this is B, and this is our C, okay? So if we just plug in the value, so this is h comma f of h. Let me write both. You don't need to write both. I'm just showing this to just compare that, okay? So our h is, as we know, negative b over 2a. So b is 8 here, a is negative 2, and we have a negative here as well. So overall, the negative will get cancelled, and we'll have 8 over 4, that's 2. And we want to see the functional value there as well, okay? So that's actually our k. Let me avoid writing that. We don't need to define that anyway. But if you want, you can always do that. You can write that as k, because that's the functional value anyway. Okay, you can do that. So the functional value is at f of 2, which is, if I plug in 2 in place of the original function, 2 squared plus 8 times 2 minus 3, it will give us a 5. So clearly the vertex is, again, you don't need to write it. If you don't want, you can avoid writing this. All you need is the functional value, which is 2. So vertex is 2, 5. That's your answer. Okay. Now, what's the axis of symmetry? We know that that is basically x equals h, or in other words, x equals b over 2a. We know the value of h, don't we? We know that h, the value of h is 2. So our axis of symmetry on this occasion will be x equals 2.